Okay, so here's a question I'm going to ask you to solve by whatever method you think is most reasonable. But when I look at this, I see they're both solves for y. There's one letter by itself. So you could do substitution, although the problem is you have like a lot of fractions here, two fractions. So this actually, these are in slope-intercept form. It lends itself to graphing. I showed you how to do this on the calculator in the other video. I just wanted to refresh your memory how you would do it if you just had graph paper. For whatever reason, my graph paper is a little bit hinky here. You can't see this line, but there is a line there. So all you're going to do is, if they're in slope-intercept form, is graph them. The y-intercept is -6. 1, 2, 3, 4, 5, 6. And from here we have a slope of 2/3, so we're going to go up 2 over 3. Up 2 over 3. Up 2 over 3. Okay? My other equation is going to have a y-intercept of 1. And this one is going down 1 over 2 because the slope is -1/2. Down 1 over 2. And this is beautiful because you can see, I never even drew my first line, that when you graph these, there is one ordered pair that satisfies both the red line and the blue line. So there will be one solution. So the solution to this system, if you counted over from the origin, it'd be 6 over 2 down. And that solution is 6, -2. You can plug that in to make sure you're right. 2/3 times 6 is 4. 4 minus 6 is the y value of -2. -1/2 times 6 is -3, plus 1 is -2. So I know it works. All right, that's if you didn't use your graphing calculator and you just did it by hand, which we had practiced numerous times. You might be more comfortable with that.